Imagine you're sending a message to a friend in another city. Hey, how's it going? It doesn't arrive right away. 1 second, 2, sometimes 5. You think, why is it taking so long? Now look up at the sky. Light from the sun takes 8 minutes and 20 seconds to reach us. If the sun went out right now, we'd still see it for another 8 minutes, as if everything were fine. Light from the nearest star takes 4 years and 3 months to get here, from distant galaxies billions of years. Why, in such a vast and powerful universe, do news travel so slowly? Why not instantly? Today, we'll unravel this mystery together. It'll be like a detective story. By the end of the video, you'll look at the stars in a completely different way. Ready? Let's go. Imagine you're opening a map on your phone. If the phone immediately showed the entire Earth, every house, every car, every tree on the planet, every plane in the sky, what would happen? The phone would instantly overheat, the screen would start flickering, the app would crash, and the battery would die in seconds. Because calculating and displaying billions of details at once, even for the most powerful phone. That's why smart apps only show what's near you. The rest is hidden. Not because it doesn't exist, but because it doesn't need to be calculated yet. Now imagine that the entire universe works exactly the same way. If any information traveled instantly, then every star, every particle would have to know about everything else right now. It'd be like your phone trying to display the entire universe at once. It would just burn out. That's why nature imposed a strict rule. Nothing can transmit information faster than the speed of light. 299,792,458 meters per second. This isn't a random number. It's the maximum refresh speed of our entire reality. Why this speed exactly? Why can't it be faster than light? Because if information arrived faster, it would break the most important rule of life. Cause always comes before effect. Imagine you're writing a letter to a friend. It takes 3 days by mail. He replies after another 3 days. Everything makes sense. Now imagine the letter arrives instantly, or even faster than you wrote it. Your friend reads it tomorrow before you wrote it today. He replies, "Please don't write that letter." You read the response and decide not to write it. But then, where did the letter come from? It creates a paradox. Reality gets tangled in an infinite loop and breaks. To prevent this, nature set an invisible boundary, the light cone. Everything inside it can affect you right now. Everything out doesn't exist for you yet. It'll load only when the light reaches you. It's like your life is a movie. You only see what's in the frame right now. Many people think, what if we still find a way to outrun light? Let's see what actually happened. In 2011, the whole world exploded with news. Scientists in the Opera experiment launched neutrinos from Switzerland to Italy. Distance, 730 kilometers. They measured the time and saw the neutrinos arrived just a tiny bit faster than light. Newspapers wrote, "Einstein was wrong." People rejoiced, finally proven that faster than light is possible. But a few months later, the scientists found an error. A simple, mundane error in an optical fiber cable. Just 60 nanoseconds difference. When they fixed the cable, the neutrinos flew exactly at the speed of light. No violation. The experiment failed. Since then, scientists have conducted dozens of even more precise checks. In the 2020s, they tested the speed of light using lasers, satellites, and optical fibers. For example, GPS signals work with precision down to a billionth of a second. If the speed of light varied even slightly, GPS would be off by hundreds of meters, but it works perfectly. Laser beams between satellites and Earth, ultra-precise clocks at atomic stations, everything confirms The speed of light remains absolutely constant. Not a single experiment in the last 15 years has managed to violate it. This isn't theory, it's verified by thousands of measurements. And even quantum entanglement doesn't help. Yes, two particles are linked instantly, but you can't send a message or information through them. It's like opening two identical envelopes and finding out what's inside, but you're not transmitting anything. Information still doesn't go faster than light. And what happens when too much mass and information gather in one place? A black hole appears. Time there almost stops. It's like a computer saying, "Too much data. I can't process all this. I'll hide it behind a boundary and not show it." The most amazing discovery of recent years, the holographic principle. Many physicists, including the famous Sabine Hossenfelder, believe that our entire three-dimensional universe is actually a projection from a two-dimensional surface. Imagine a hologram on a bank card, a thin, flat film, but when light hits it, you see a volumetric 3D image. All the information about the 3D object is stored on the flat surface. Physicists say the same might be true for our universe. All information about us, about stars, about black holes is stored on a thin surface somewhere at the edge of space. We think we live in a three-dimensional world, but in reality, we're like a hologram. This is incredible efficiency. Instead of a huge 3D world, only a 2D image is stored. Optimization at the highest level. The speed of light isn't a limitation, it's protection. It's a way to prevent the entire reality from collapsing under overload. But if we really live in such an optimized simulation, then who started this massive computer? Who's monitoring the processor? And what will happen if we learn too much? We're like movie heroes who started noticing that the world loads in chunks, and when the hero gets too smart, the screenwriters either change the plot or turn off the projector. For now, enjoy the game. Look at the stars. Their light is letters from the past, and perhaps someone out is watching us too, and smiling. Subscribe to Stellar Ledger. Here we search for real cracks in reality. See you soon.